Good afternoon, everyone. Myself, Sunil Devanshi from CSE Career. So, as part of my machine learning and techniques laboratory of second experiment, we are going to look after feature selection and feature extraction and how it going to influence the given data set of Toyota.csv. So, the main aim of this experiment is to select the features which would help in dimensionality reduction as a part of a dimensional reduction technique. So which will help us to overcome the noises in the data by taking the only important features and extracting those important features in our machine learning algorithms. So as a part of it, first we are going to import the data set, which is Toyota data set. And then next we are going to drop the column which is guarantee and then those. So here we remove the columns from the data set since they are not required for the further analysis. So the next question, we are going to detect the outliers using IQR and drop columns. In this step, we detect numerical columns that contain outliers using IQR, which is interquartile range. Method, display those columns and remove those from the data set. So these are the outliers column which are nothing but HP, automatic, doors, these are guarantee period and the price. So after removing that outliers, the shape of the data set would be 50 and 9, where we can see the data set has reduced from 50, 13 to 50, 9. Next, for the next step, we are going to drop the columns with the variance which is less than 10%. So first we are creating a temporary DF variable and where we are going to copy the overall data set into the temp DF. And then here we identify the numerical columns with very low variance, which is less than 10, which means they do not contribute much information. So we remove them from the dataset and which we store them into the tempdf variable. So once after removing and replacing true, which means removing the columns, we would get the shape of the dataset as 50, 8, where we can see the dataset shape is dropped from 50, 13 to 50, 8. So the next thing we are going to identify the input columns with correlation which is less than 0.2. Now we are going to identify the columns with the correlation which has 0.2 with the column named price. In this step we identify the input futures that have a correlation with less than 0.2 with the target variable price. So we are going to copy into a temporary variable and then going to check the correlation using the correlation method and then return the shape of the dataset. Next, we are going to identify the highly correlated feature pairs which is greater than 80%. So as before we are going to copy the whole dataset into a temporary variable and then performing the measures. So using drop method you are going to remove the price and checking for the correlation with the absolute method. So after iterating, we are going to check the correlation between the pairs which is more than 80%. Whereas, as you can see in the output, the manufacturing month and age are correlated pairs which have the maximum correlation, which means 80% correlation between the pairs. So are paired together. For the next thing, we are going to identify and drop one feature from highly correlated pairs. Here, from each highly correlated feature pairs, we remove one feature based on lower correlation with respect to the target variable, which is nothing but price. So using correlation, we're going to check the price correlation and then drop the axis and check whether correlation absolute. And once after the correlation is done between the feature price with respect to the target variable, target column price, where we'll be returning the temporary DF, which is nothing but the variable which have copied the whole data set and trying to do the feature selection and extraction. And the data set shape would be written as 50, 12. For the next thing, we are going to separate input and target variable. So X would be all the input features and Y would be the target variable. In machine learning techniques and algorithms, which we are going to tell Y is called target variable and which is also known as dependent variable. And X are independent variables where the Y is known as dependent because it depends on the independent variables to predict. For the next one, we are going to perform univariate feature selection using select best from scikit-learn library. So here we perform feature selection using scikit-best method with chi-square scoring function and select the top 10 important features. So using select k-best imported from scikit-learn library, we are going to fit the selector model and x and y variables into the new variable and going to retrieve the most important and features. Next, we are going to estimate the mutual information score for the input features to the target variable price. So in this step, we calculate the mutual information score between input features and the target variable price to identify the most informative features. So in this, we are going to use the info regression model, which is imported from sklearn feature selection. And using this series, we are going to fit the model into pd.series and then retrieve the highest feature. For the next one, feature extraction using PA. So the main aim of this question is to perform a feature extraction using PCA by step-by-step Python code. So which is nothing but first we are going to import all the data set into the temporary df variable and then dropping the column price. And then to handle the missing values, we are going to fill 0 in the place of missing values using fill no column. And then using mean method, we are going to check the mean to find the PC principal component analysis, which is nothing but PC. And derived, and then we are going to convert this into eigenvectors and eigenvalues. So here we would get the PCA matrix. For the next one, we are going to perform the feature extraction using LDA. In this step, we apply linear discriminant analysis using scikit-learn library and extract the first two LDA components. So we are going to import uh, linear discriminant analysis from scikit-learn library and then dropping the price axis is given and handling the null values and fitting the whole model into the x and y independent and dependent variables into the variable and performing the feature extraction. For the next question, we are going to see about image extraction feature. So here we read the image which is given lena.png as a file name and compute the pixel by pixel mean value and display the extracted image feature. So you can see the image is this and the pixel by pixel extracted image would be this. So as a result and concluding this experiment, the dimensionality reduction experiment shows that reducing dimensions can increase accuracy from 80 to 97% and which also improve the efficiency of a model to outperform other methods on high dimensional data. And also it classifies a complete accuracy on complex datasets. It also gained the performance on extracting the minimal features, minimizes the noise in data, leading to faster training and then higher accuracy. Thank you.